Hey physicists, I promised you a video on dispersion, and here it is. So, a couple of days ago, when we were doing our marching band analogy, you remember that we were marching from air into mud. And as we did so, our step lengths changed, and as a result, the light bent. So we know that the light bends, and we know that it bends in different directions depending on what type of medium you're in. So today we're going to talk about a little bit about when light enters that new medium. We know that it bends, so this is what we already know, okay? And we want to figure out how far does it bend. There are three different factors that we're going to talk about. We're going to talk about one today and then a couple in a couple of days, but I'm just going to list out all three factors so we've got all three of them in our brains. The first one that helps to dictate how far it bends is the wavelength of the light. The second is the angle of incidence. Or the angle that the light is coming in, that's theta I from our picture before. And then number three is the material or the medium that the light is in or is traveling in, and the medium that it enters. So today we're going to focus on the wavelength of light piece, this one here, okay, and the result of the change in wavelength and what that's called. So I'm going to give you a quick example here first. So this this picture shows light starting out in air and moving into this nice triangle of glass. Okay, or sometimes known as a prism, okay, and then it moves back into the air. So we just want to look for a couple moments here at what happens to this light. This is blue light, so this is light with a very small wavelength when we're talking on the order of the visible light part of the spectrum. As we watch this light, so remember we're going to draw our normal line. Normal means perpendicular to the surface, so I'm trying to draw a line that's about perpendicular to this. Okay, and we can see that the angle in, that's theta I, as compared to theta R, theta I is bigger. It's bending toward the normal. It's bending toward the normal, so we're going to just write this down. So from air into glass, the light bends toward the normal, which should not be a surprise because the glass is a more optically dense medium. So it's going to bend toward the normal, which makes sense. And then if we look at what's happening to the blue light as it leaves the prism, then we can draw another normal line. And we see that as it goes from the glass into the air, then it actually is going to bend away from the normal. So we'll just write that down so that we can see that we see the same deal. So from glass to air, the light bends away from the normal. And the fun thing about this is, unlike the ones that we were looking at before, we've got two bends that are happening, and they're not ending up parallel to one another because the two spaces where the media changes are not parallel to one another. So we've got this nice bending that's happening. So again, I pointed out this was blue light in this case. The fun and interesting thing is that when we look at different colors of light, they bend different amounts. So I'm going to show you a picture here that's got not only blue light, but it also has red light. So we can see that the blue light bends. So this first picture right here is the same as the picture that I had on the other page. This one right here is that same one. The red light does the same thing, but you'll notice just from looking at those angles that the red light bends less than the blue light did when it entered the glass, and it bends again less when it enters back into the air. So if you just look at the two pictures, 1 and 2, you can't really see a big difference, but it is when you look at that third image there, that third piece, that you can see that the light bends a very different amount for the red versus the blue. Now, this prism is interesting and a little bit different from just a regular piece of glass like a window, because you can see that this white light that comes in, I'm going to highlight it with yellow just so you can kind of identify what's going on. This white light, and remember, white is the combination of all the colors, that white light is separating out a little bit when it goes into the glass. And then because of the geometry of that prism, it's going to separate out even more as it leaves the glass or leaves the prism. And you can imagine then that if you've got red light, which is at one extreme at the very high wavelength side, and you've got blue, which is at the low extreme at the very small wavelength side, that all of the other colors are going to fit in the middle. So this gives you the rainbow, right? So dispersion of light, we're going to actually go ahead and write this down and define it. Dispersion is the separation of white light, remember, which has all of the colors, into its component colors. And that is the generation of the rainbow. That is what we see with crystals. That's what we see with prisms. That's what we see on the front of the Pink Floyd album cover, right? That's all of those processes are really just breaking that white light down into the pieces. Hope that helps make sense. We'll jump in from there next time.